Okay, let's get started. Oh wow, the sound is on. Thanks for showing up and avoiding the sun. My name is Bert Oosterhoff. I work in the European organization at Informatica as a director of technology. The EMEA region, which means from North Cape to Cape Town, sort of. It's good. It's almost one time zone. The presentation, we're happy to have one of our customers, BICS, presenting to you what they have done or planning to do with predictive analytics and using the Hadoop stack for that. Belgacom, which is sort of now Proximus, is a customer of Informatica's for a long time, starting with the data integration platform. So what the agenda is I'll do a short introduction, then hand over to Daniela, which again I'm happy that she's here. She will be speaking in English, of course, like me, but for both of us it's not our primary language, so if you have questions, just write them up and ask them at the end. She will then cover who BICS is, what they do, and what they do with the business intelligence space and how they use big data for that. And then the remaining time after she finished, I'll explain a bit more about what Informatica does with the big data platform and how we can help organizations using the platform in combination with other types of data infrastructures, being it on-premise with traditional systems, being it in the cloud with storage or applications that they use in the cloud infrastructure. If you follow the space, by the way, before we start, how many of you are Hadoop type of development persons? 1, 2, 3, a few. How many of you on the business side? That's good too. It's always funny if you ask to raise hands. This morning in the keynote, I don't know if you were there, the question was how many people use this personal device to monitor your heartbeat? I think nobody raised a hand and said, oh, excellent, great number. So it's always good to see that. As you follow this space, Informatica has been around for a while. We focused on data integration ever from the beginning, and in early of this century, so 22, 23, we had our data analytics platform where we say data should be treated as a first-class citizen in organizations, and as should be money and people and products. And it's good to see that after so many years now, data is becoming the central point of organizations. The reason I show this is that we've been around for a while, but also if you saw the news, Informatica will be a private company if everything goes as it's planned, so we will no longer be on the stock exchange in a couple of months. As we've been around and also always focused on data, you see that we've been in various spaces. So coming from data integration, where we started, also moved into the cloud space as one of the first data integration platforms, adding data quality, data profiling functionality to the platform, adding things like masking for privacy, adding archiving functionality. Again, it's moving data from one environment to the other, whether it's from a source to a target, or whether from an operational system to a data warehouse, or from an SAP system to Hadoop, or from an application to an archive. For us, it's all data movement and data logistics. And that's what we work on. And if you see these slides, we're also recognized by the analyst as leader in this space. And it's not only Gartner, it's also Forrester and others that recognize us in this space, as we have helped large organizations to move in that direction. So why are we in this big data space? Well, first of all, as you've seen, big data is not only about the volume, it's also about the complexity. And if you look at this picture, you see that a lot of innovations have come over the years, from mainframes to client servers to ERP systems to web applications to cloud services, etc. And also new players are coming here. Also interesting to see is that hardly any organization is removing these parts. There's still mainframes, there's still Oracle applications, there's SAP applications, there's web applications, etc., etc. And there's now IoT, Internet of Things applications and development tools. They all use data, create data, and that data needs to be managed and monitored in the same way as it needed to be managed in the past. So Hadoop is an extension to the infrastructure in large organizations, as you know, but sometimes Hadoop is sort of seen as a sort of isolated new thing, and we got confirmation from our customers that it needs to be treated as a significant, valuable resource, but with the right management, governance, security, etc., that is also applied to the rest of the data. So, if you then look at this evolution of systems and applications, there's new business initiatives possible. Not only because those requirements were not there yet, but now they're affordable because the Hadoop stack is open source, it's affordable, it's scalable. So now questions that could not be answered in the past because they were just too expensive can now be asked and solved. And that goes across industry. It's not only government, it's not only financial services, it's not only telco. All companies, large organizations want to do these type of use cases. And to be able to do that, they need to combine data that's in operational systems with new types of data that is coming from devices, from logs, from tweets, from Facebook likes, from whatever. They can get to data to get value out of that data and use it in the business processes. Should move forward. If the battery is still working. Can you move it forward? Ah, okay. Let's see. Okay, if we talk to customers and they want to realize these things, then you see that expensive data scientists, data analysts spend a lot of time in figuring out what data is available to them. They spend 80% of the time finding out where the data is, what the semantics are, what the quality of the data is before they can use it. These are all quotes from reports, which if you receive the PowerPoints, there will be reference to those reports. And this is an area where we are also seeing more demand for products where people would like to see the data, prepare the data, use the data, and reuse them with other people in the business side. So making data and data acquisition, data preparation more as a self-service function instead of an IT function. In this whole process, you have competencies and disciplines, of course, needed, whether it's on the exploration side, where you have data scientists, subject matter experts, working on the discovery phase, finding stuff that they've not found before, using data for predictive analytics type of solutions, which we heard about in a minute. But also on the management and governance side, Hadoop is not new in that way. If we talk to the telcos, the KPN maybe in the room, Belgacom, they also have to do with legislation. Data cannot be stored or used if it's not anonymized first. So those are things that are needed and required to a Hadoop platform too. And then of course you want to operationalize and use the data, get value out of the data in production environment, making this whole system development lifecycle agile. If the business needs something, they don't want to wait a few months for IT to be ready. They have to have the right tools to get that job done. So looking at where we see the use cases for big data, we see a few things. We see first companies are starting just as a pilot phase. Okay, we expect to have a lot of value. Let's do a pilot. We pick a Hadoop distribution, play around with it, see if we can get some results, get in a learning exercise. The next phase, we see that it's used as a data warehouse optimization, data warehouse offloading environment, because that's an easy use case. You have expensive data warehouse, a lot of cost attached to that, and you want to maybe reduce the cost and add value to it by adding more data from other environments to it and use that in an analytic space. Then use it for data discovery, getting more value out, and then put it in a real-time space where real-time metrics or metrics from large volumes of data can be used in an operational business process. So this journey, a lot of companies have started, depending on the maturity. People are here or maybe more on the right. And the whole growth and evolution of this can be best implemented in our opinion, and we get support from that from a lot of analysts, is putting it into sort of a data lake concept. putting the data that you have and that may be used for analytics or operational purposes, put it into a sort of lake, and then get value out of that, put intelligence on it, and put analytics functionality on top of that. So from the infrastructure on the left, getting data in a lake, use it for the business purposes, but all with the same environment, same governance, same security rules, and then make it possible and available to the business users. So this is sort of the introduction where we come from and how we think we can help you, all with these tools as the big data Hadoop stack can be extended to the traditional environment to create this hybrid environment. So in BICS, they have also seen this journey. They have started the journey, and they've come to some conclusions. And I'm happy to introduce Daniela to talk about how BICS has started this journey and where they are now.
Yeah, it's better. Okay, I'm Danielle Cana, and I'm happy to be here to share our experience at BICS in the area of big data and Hadoop. Following the agenda presented by Beth, I will start by introducing my company, and I will more specifically talk about what we are doing in the BI department. This will give me the opportunity to talk about our big data initiative and to share with you the challenge that we have faced and how BICS is leveraging Hadoop to overcome those challenges. Let's start by introducing BICS. BICS stands for Belgacom International Carrier Services. It was created 10 years ago in 2005, and our mission is to deliver best-in-class wholesale solution to telecom service providers worldwide. BICS is a joint venture between Belgacom, Belgacom, which is the Belgian leader in fixed and mobile communication, Swisscom, and MTN, one of the leading telecom service provider in Africa and in the Middle East. We have more than 700 customers, including 400 mobile operators. We are just over 400 employees located in our offices worldwide in United States, Switzerland, Singapore, Belgium, Switzerland. Our headquarters is here in Brussels. So what is our business? As I just mentioned, BICS customers are mobile operators. So imagine that you are a mobile operator in France, for instance, and you want to give to your subscriber the possibility to make calls or to send messages to people outside of your country, in Belgium, in the United States, or in South Africa. You need somebody to carry your traffic from your home network to the remote destinations. BICS can offer many solutions to carry any type of telecom traffic all over the world. With a network of more than 100 points of presence, we can reach 1,000 destinations. BICS is the top 3 voice carrier in the world, and in Africa we are the number 1. In the area of mobile data, we are the world leader. One important service for mobile data is the roaming service. Why? Because imagine that you are, again, this mobile operator in France. You probably want to give to your subscriber the possibility to keep making calls or sending messages even when they are traveling. To be able to do that, you need to set some agreement with other mobile operators so that they will allow your customer to use their network resource when they will visit your network. BICS offer many solutions to set up and to manage this kind of relationships, and also to expand the roaming coverage of the mobile operator faster. So now that we know a little bit more about what we are doing at BICS, let's talk about the BI area. To explain what we are doing, I will take the example of one of our projects, the SMART project. The goal of this initiative was to give to our mobile operator a complete view of their roaming activity. And how do we do that? We connect our network probe, and every minute we will fetch all the data that are carried by BICS and use the Informatica Power Center and Teradata We will compute some analytic on this data and send the result to our reporting tool, QuickView, as well as we will store it into our data warehouse. As a result, we will provide some report to our customer, which will help them to monitor the performance of their network, to follow the evolution of their traffic, to analyze the behavior of their customer, and also to monitor and track and troubleshoot at real time the issue that the specific customer can experience during this roaming activity. Let me show you some example. So here, for instance, in that report, which is refreshed in a near real-time mode, a customer can see with a latency of about 6 minutes the status of his traffic on his network. When I say 6 minutes, it means that it is only a delay of 6 minutes between the time the event actually occurs in the network and the time it is visible on that report. And we can see directly how many transactions were successful, how many transactions had failed, which are the country or the operator which are calling the most on our network, and on the other side, which country or which operator our own subscribers are calling the most. In case of failure, we can see which type of message are mostly impacted by the error, or which type of error we mostly face on our network. And all this information is really in a near real-time mode. Another type of report we are providing is this one where we really analyze the behavior of the subscriber. For instance, a mobile operator can know how his subscriber behave when they are traveling. Most of you are not living here in Belgium, so you are probably doing some roaming now. Using this kind of report, your home operator can see how many of you are completely silent, meaning you are not using your data connection right now, and how many of you are using their data connection, and what is the volume of data you are using. So this kind of information can really help them to make some target marketing campaign and improve their roaming activity. Another type of report we are providing, and this one is very interesting, is this interface where a mobile operator can enter the phone number of one of his subscribers, pick up any date in the last 30 days, and get the status of the roaming activity of his subscriber. Meaning that if he selects the current date, he can really see and troubleshoot at real time any issue this customer is facing during his roaming activity. Okay, these kind of reports are very nice and very useful to our customer, but building them comes at a substantial cost. The first one is the storage cost, because we are not just providing some summary report, but we store and give to our customer a visibility of the very detailed information, and this for more than 30 days of data. So to give an idea about the volume I'm talking about, only for one type of our traffic, the signaling traffic, we are almost about 2 billion of transactions daily, which is more than 1 terabyte of data. And we have seen that BICS is not only carry one type of traffic. For telco people, we are a lot of traffic of 2G, 3G, and even 4G technologies. And with the fact that people are traveling more and more, and we have the explosion of devices like laptop, smartphone, the estimated growth of this kind of traffic is more than 100% per year. It means that we really need to find a solution to rationalize our storage cost. But storage is not our only concern, because we provide near real-time reporting on this huge volume of data, meaning that we need a platform which is powerful enough to process this huge volume of data as fast as possible and keep the same SLA independently of the fact that the volume will keep growing month after month. So this is how we got into the big data world. And we think about Hadoop. Why Hadoop? Because Hadoop is the world-leading platform for the processing of this kind of volume of data. It offers a cluster of low-cost commodity servers which will work together to provide the storage capacity and the processing power that we need, and which is exactly what we are looking for. And so instead of investing in every year in a big, powerful, and very expensive server to handle this fast-growing volume of data, we can size the cluster to our current need and keep adding low-cost commodity server with the growth of our data. And the beauty of this solution is that the storage capacity and the processing power will evolve linearly with the addition of new nodes to the cluster. So when you decide to go for Hadoop, you have to answer many questions. Which distribution? Are you going to set up your cluster by yourself, or is it better to choose an appliance? And how do you integrate this new platform with your existing IT architecture? So our approach was to set up a POC, first to check that Hadoop can really answer our use case, and also have some element of response for these questions. We decide to go for an appliance, the Teradata appliance, which is a Nortonworks distribution. Why? Because we don't have so many experience in setting up this kind of complex and fast-changing cluster. And we choose to have a solution which is pre-configured, predefined, and ready to use in a plug-and-play mode. And we also wanted to faster the integration of this platform. We want our first result for the next quarter. So, also, the POC shows that if Hadoop is performing very well when it comes to process a big volume of data, when you try to process a small amount of data like the one we are fetching every minute in our network, the overhead caused by the communication between all the node in the cluster make Hadoop less performing than a traditional database. So we therefore decide to keep in our traditional database only our real-time process, and to move to Hadoop the processing of all our hourly or daily or any process which can live with a latency of more than 15 minutes. Graphically, our new architecture looks like this, where on the upper branch, we will only fetch from our network the data need to feed our near real-time reporting. And this will be done by the means of Informatica Power Center and Teradata like today. But in parallel to that, we will also feed our Hadoop cluster with all the data which are available in the network, and using Informatica Big Data Edition, we will compute our hourly, dailies, and all batch analytics, and also feed our reporting tool. So why Informatica Big Data? As I already explained, we are using extensively Informatica Power Center, and the advantage of this tool, the Big Data Edition, is that it gives us a graphical interface with some predefined function, and this will help us to focus on our BI logic independently of the fact that the execution will be done on Hadoop, meaning that any ETL developer today can work on Hadoop without being a Hadoop expert. Another advantage is the fact that we can even already reuse some existing code that we have with Power Center, and with few change, push the execution to Hadoop. This will help us to redistribute the workload of our traditional database. The tool will also give us the possibility to use one single tool to feed Hadoop with any type of data, to easily move the data in and out our Hadoop cluster. And one interesting feature is the data profiling that we aim to use to analyze the data in our cluster and also to troubleshoot any data quality issue. So what are our next steps? What we have already started is the setup of the lower branch of my architecture. So we are currently feeding Hadoop with the data coming from our network. And the first step will be move all the detailed information that takes a lot of space on our traditional database to our cluster. So one big challenge is to be able to use the tracking information, the one where you can track all the detail of the activity based on the phone number of one user directly in Hadoop instead of the traditional database and within the same SLA of less than 1 minute. So when we will move all our detailed data to Hadoop and also all our long-term processing, we will be able to go to the next phase, which consists to build new analytics from our cluster. And one example of the thing that we want to start propose to our customer is today we have a recurrent request to get more predictive reporting. So the roaming traffic is something which is very seasonal. We have a peak during the holidays and at the end of the year. And if we can store more than 1 month of data, meaning 1 year or 2 years of data, we can really use this data, compute some analytics on them, and predict the evolution of the traffic for our customer, which will help them to really handle their network capacity and other stuff like this. This is it for me. Thank you for your attention.
I don't know if it's easier maybe to do questions for this part now. We still have, so I can fill up the time later. Any urgent question now for BICS?
What's your data like? Is it directed to your commodity hardware? What data is underlying your commodity hardware in your Hadoop cluster? Is that direct attached storage or a SAN, or what's the data, the storage underneath your servers?
It's the appliance, it's
an
HDFS.
appliance.
It's an appliance.
Yes, the data appliance.
It contains it's a data store.
It's HDFS, I guess.
So it's we have 10 data nodes, which each have about 48 terabyte of storage each.
And what's that storage? That's in the appliance.
That's
Yes.
the appliance, so it's 10 physical servers all combined in one dedicated track.
Okay.
So storage is a very efficient.
Okay.
Yes.
One more question.
Hello. How big was your POC team?
Oh, it was a team of 6 persons. 6 persons, yes.
6 person for 12 weeks. You said 12 weeks?
Is it?
I don't know. I thought you said 12 weeks for the POC.
No, it was 15 weeks. Its last 15 weeks. It was just the goal was just to set up quickly a commodity cluster and to try to implement the most important of our use case and to see if it works. or it was working on Hadoop. So, but it was not that simple to implement the cluster. That's why we say, oh, if we have to deal with this kind of things, we will not be able to start with Hadoop in the next quarter. So maybe it is more safe to go for an appliance, and we know that we don't have to worry about the platform. We can directly work on our use case and try to get the best of our new platform.
Between the 6 people, what skills did you bring to the project?
I mean, we outsourced it to Haricent. I mean, we did a RFP, and we had a fixed time project to set up this POC and to get the conclusion that we want to get.
Thank you.
Is it okay? Sorry.
Okay, one more, and then Loy will continue. We can do afterwards.
Thank you. I just wonder what this transition to Hadoop means for Teradata in your business. Will you continue to invest in Teradata? Does the core Teradata platform get wound down over time now you're moving to Hadoop?
The thing is, today Hadoop is not able to completely replace a traditional database, especially a powerful one like Teradata. So what we want to do is to really only keep on Teradata what is critical in terms of latency. We will offload a lot of data, all the detailed information, which is not, which were only stored for any long-term analysis, and so we will offload all of them and reduce the amount of space and processing power we are currently using our Teradata, and move more and more things to Hadoop.
Okay, thank you, Daniela. To summarize what Informatica is bringing to the table for the whole big data platform, I've got an overview slide here where we can see all the aspects that are in this space. Of course, you first have the injection space, where you see a lot of companies starting with just programmers and writing big code, big scripts to get the data and move it into HDFS or through a Hive interface into the big data. We think that there's many different ways of ingesting data, and you want to make it as easy as possible with a graphical user interface, defining the connections, doing either in batch or just capture changes from a transactional system, or get streaming data from devices, from IoT stuff, from network probes, from wherever, and then decide what you want to do with it. So on the data management side, you have what we call the virtual data machine. It's branded in Informatica as FIBE for our virtual data machine, which actually means that you have some logic and you execute it wherever you want. So you can have, maybe people that know Informatica for a long time, you have the Power Center product where you have a source, you do some transformation and you have a target, either in batch or in real time. Well, that same logic, you can also push it down and have that logic executed, for example, on a Teradata database. And since the last couple of years, you also now have the opportunity to execute that in a Hadoop platform. Yeah, so that's why we call it virtual. You decide where you execute it. And of course, that functionality is not 100% complete, because some functionality that we have in Power Center are not in a Hive query. So what we do is we add functions that can be deployed on all the nodes in the cluster of Hadoop. So you can still use Hive queries with that specific transformation function. We also think, and some analysts say it even blunt, that big data without master data is useless. I don't always agree with it, but I think there's a lot of added value if you have master data where you have complete insight in your customer or product, and you extend that with knowledge about everything you know about a customer, and maybe have that data which is in a Hadoop stack or another analytics stack, and combine that with master data to find the next best offer, for example, to a customer. As an example of that, we work in a similar space as where BICS is working with a telco in India, where they also want to do the next best offer. So they get data from the network switches. They know if a call is failing, depending on who that customer is. If it's a person that is maybe a child making 2 calls a month, they don't do nothing. But if they know that this customer that has a few disruptions in his call, and they know it's an important customer, they may make him an offer maybe that he can get a free service for another 2 months or whatever. Yeah. So immediately creating customer experience based on real-time data combined of big data platform with master data platform. Other aspect of this whole data management stack is the security. If you have security rules where you say some people in my organization are not allowed to see to this part of my Oracle database, for example, and then you have also data from that customer in Hadoop, why would you use another tool, another environment to have the same security rules in Hadoop? We think that should be part of an enterprise data governance masking and security environment, so that if you have the rule that this information, social security numbers related to personal information, whether it's in Hadoop or whether it's in Oracle, should be masked if a person is allowed to see use the application but not see the data. So security should be part of it, and then of course the storage. It should be irrelevant for the business users whether it's stored in a Hadoop cluster or in another data store. Maybe there are some specific stores, like also in the Teradata story, they also have the Hortonworks environment, they have the Teradata appliance, and they have Astrodata for their graph processing. Makes sense. From a business perspective, it doesn't. The business wants to use the data, wants to profile the data, wants to create metrics out of the data. So we abstract that level to the logical environment and not make it persistent into the coding itself. Another example, if you write some logic in a MapReduce code and you have some program nice functionality and you need that same functionality in an Oracle database, you can't use it, right? So that's the idea. Abstract the logic, execute it where you need it, and reuse it where possible and applicable. So then on the delivery side, you can have different types of applications on the data. You can say, okay, I've got a data integration hub type of solution where applications publish data in a lake, whatever you want to call it. Yeah, some people call it a lake, others say it's a data swamp or an ocean. But you store it somewhere, and then you have applications using it. So some applications want to use it for all the changes that come from an HR system. And maybe another system says, okay, I need to have these changes every month because my sales system is using new employee numbers. So it's a different use case, but it can be implemented in the same stack. Virtualization. Sometimes you need quick results. You have some data in your data warehouse. You want to have that logical view of customer and expand it and extend it with data that is not in the data warehouse. Then data virtualization comes in place. So augmenting and enriching the data warehouse environment with data warehouse optimization, offloading. We have some partnership with Cisco where we can have this data warehouse offloading, and where they can use either the Informatica virtualization or the Cisco virtualization. The business decides what is needed from a functional perspective here. And then of course, data as a service. Some applications need data. You can provide that as a service, whatever standard you're using. Most of the time, nowadays, it's a REST-based interface where you can have services to request data, and then the environment here in the middle will take care of combining the data wherever it sits in Hadoop or in a relational database. And then the other thing is event-based processing. Another paradigm, another pattern for data logistics and data integration. I already mentioned the example of deep packet inspection. We work with a company called Cosmos, for example, they have a software probe for network DPI. They can recognize SMS and URLs and Facebook and tweets and stuff like that. So in the combination with Informatica technology, we can get that data from the probe and then make rules on it, complex rules. Like if this is an SMS and it's for this and this customer, I will not allow it because he doesn't have SMS in his subscription. Yeah, so you can make products more tailored on real-time processing. And of course, there's tons of examples of complex event processing in this domain. Also, and that's to wrap up, the same thing can also be used for streaming. We work with large consortiums on the IoT, Internet of Things space, where devices are generating data used for analytics and used for real-time analytics. Some companies have a platform that is using and managing millions and millions of devices simultaneously on one Hadoop platform. Again, that can be historical data, but it can also be used in real-time context. Finally, archiving. Archiving sometimes is needed for regulatory compliance. You have to save the data for so many years, but then of course you want to use it in as affordable environment as possible, compressed but still accessible by the business. So we also, in our archiving solution, we use the Hadoop to store the data compressed and have an index available so that the business still can do queries on the archived data. So all in all, it's an environment that can be extended and expanded. Message from us is make as much as possible an abstraction between logic and deployment so that you're not stuck in HTTP version 1 test 0.8.5 whatever, but that you abstract that level and that you can move forward. And if you want to use Spark next year, you can move to Spark. If you want to use TES next month, you can use TES. But keep the logic of what you want to do with data, how you want to manage and govern data separate from the persistent. And that is what I wanted to share with you today. My time is up, so any questions for Daniela or for me? I'm open to questions now. Thank you. No more questions? Okay, well, Daniela and myself, we're still around here, so if you want to have some one-on-one questions, we're available for that. Thanks a lot, and enjoy the rest of the day.